Assalamu alaikum everyone. This is Probability and Statistics for Engineer course in the Department of Civil Engineering, International Islamic University. Today we will discuss about one example related to simple linear regression. As we have already discussed simple linear regression and the regression equation in our previous lecture, in this lecture we will solve one example using that equation. Now let's start. So if you recall a regression equation, that is y is equal to beta naught plus beta 1 x, where x is actually the independent variable and y here is dependent variable. So y will depend on this x if you have beta naught and beta 1 value known. So for beta 1 we have an equation, and for beta naught we have another equation. So by if we want to predict y on the basis of x, we will first determine these two terms. So I have already explained what is beta naught and what is beta 1. So beta naught is actually y-intercept, and it is the estimated average value of y. It is the value of y when the value of x is 0. So at y-intercept, x is equal to 0. Now beta 1 is the estimated change in the average value of y as a result of 1 unit change in x. As I have already mentioned, that beta 1 is basically the slope of line, that is, so y is equal to beta naught plus beta 1 x, and this can be represented by a line. So this is a line with an y-intercept beta naught, and beta 1 is slope of that line if we have x and y value. So that's quite simple. Now let's solve a very simple example and develop an equation, regression equation, by using dependent and independent variable. So a real estate agent wishes to examine the relationship between the selling price of home and its size. So we need to determine the relationship between selling price of home and size of home, which is actually area of home in square feet. So if a random sample of 10 houses are selected, if we check 10 different houses and we consider our dependent variable, that is y, this house price in $1,000. So if we have house price as dependent variable and area, that is square feet, as independent variable, so we need to determine a relationship between that, and for that we need to have a data of 10 houses. So if we are given data of 10 houses with y equal to y actually represented the house price and x representing the square feet or area. So if this is the data with us, we can develop first a scatter plot. So if we keep square feet on x-axis and house price on the y-axis, and we put these values, if we put these values and plot a graph, so it will give us some data point on a scatter plot. And we can see here, if we visualize that, we can see here that there is an increasing trend here. So let's develop an equation for that. We have a number of statistical programs available. One of them is Minitab software. Another one is SPSS, that is statistical program for social sciences. Another one we have R software. R is a very famous software for statistical analysis. We can also perform these kind of analysis by using MS Excel. So MS Excel is another type. And what we do there, we just put value of x and value of y. We have if we have a sample of 10 x and 10 y's, then we put these 10 sample in that software, and that it generate a table like this. It generate a table like this, and we are not interested in all of these terms right now. We are just interested in these term. Now here, this constant is actually beta naught, and square feet, the term in front of square feet, that is 0.109, is beta 1. So if we want to write an equation from that, so we can see here house price is equal to 98.24 plus 0.1098 into square feet. So this is our regression equation with beta naught value 98 and beta 1 equal to 0.1098. So if we embed this data set that I have previously shown you, if I embed this data set in the software, then it will automatically generate result like this by performing some calculation at back end. But I will use this data to determine beta naught and beta 1, and then solve, and then I will develop that equation. So if you see here, that is basically the equation. This equation is basically representing this straight line, and if we extend that straight line, so it will, if we extend that line, let me erase all. So this is a line, and if I extend that line, it will intersect at somewhere at 98.24. so at y-intercept, that is 98.24, and the slope of this line is 0.1097. So we can interpret it like this as well. Now what is 98.24? that is beta naught here. That is estimated average value of y when the value of x is 0. If x is equal to 0, is in the range of observed value. So here we cannot say that y is equal to 98.24 because we cannot have a square footage of 0. It's not possible. So we must have some value of square footage. Now let's interpret beta 1. So beta 1 here is 0.1097. So beta 1 is the estimate change. Beta 1 estimate the change in the average value of y as a result of unit change of x. So here beta 1, that is 0.1097, tell us that mean value of house increases by 0.10977 into 1000, because this x value are all in so actually these prices are all in $1000. So with 1 unit change there will be 109.77 dollar on average for each additional 1 square foot size. So if a house size increase by 1 square foot, so there will be an increase in the cost, that is 109.77 dollars. Okay, so as I said, we can use this equation for prediction. So if we have an area of 2000, so we can just embed that 2000 here in this equation and multiply by 0.1098 plus 98.25, so it will give us the price 317.85. so the predicted price for a house with 20,000 square feet is 317.85, but as it is in $1,000, so the total price is 317,850 dollars. Okay, one more thing, for a regression model we can interpolate data in this line, within this line, but remember that we cannot extrapolate this line. We cannot predict the values that are outside of this line. So we can only predict the value within this line, but we cannot predict the values outside this line. So if the maximum value that we have, from which we have developed a model, if that is 7,000, so we cannot put any value more than 7,000 in this equation to predict the price value. So that's all for this lecture, but as I said I will also solve the same problem in Excel. So let me start with that. Now let me remove all this and start with the new data. Okay, so let me take this data. Let me take the data from the slide. Okay, so I will copy this data, the house price in dollars and square feet. So I will copy that, I will transform this, I will shift that to Excel. Okay, so let me arrange its size. The size is too much. Okay, let me reduce the size. Okay, so we have let me just show that we have a house price is in 1,000, that is Y, and we have area as X. So X is our independent variable, and Y is our dependent variable. So okay, let me make some changes here. Okay, so that is our input data. Now if we see this equation, if we see the equation for beta naught and beta 1, so we need to determine xi minus x bar and yi minus y bar divided by xi minus y bar. So y bar here is actually showing me the average value. It is the average value of x. Okay, so that is the average value, and let me take the average of x y. So that is the average of y, and let me also take the average of x. So here I get average value of x. So we will use this in equation. Now we have to determine here x minus x bar. So I will develop a column that shows x minus x bar. Now x bar I can write it xm, because xm is showing me the mean value, and the mean value is 2 for okay, let's make simple, make it first for y minus y mean. So mean value for y is 286.4.5. so that is subtract mean from every value of y. I will subtract mean, and that will be 286, but I should keep it constant throughout, and the value I will receive is 41.5. Now let's break down, and similarly I have to determine the value of x minus xm, and the mean of xm is 1715, and same procedure we will also do for x, that is the value of x minus this one, and keep it constant throughout. Okay, so that is minus 315, and drag down to obtain other values. Now we have already obtained x minus x bar, yi minus y bar, and now we have to multiply these two columns. So let's multiply y minus ym and x minus xm. So if we multiply these two columns, that will give us the results. Multiply both of them, so that is that will give me the value of all y minus ym and x minus xm, and here it has a summation sign, so that summation, so I have to take sum of this. Sum of this will give me one value. Then now I will make another column, and that column will be for x minus x bar whole square. So let's make another column, x minus it's x minus x m whole square, that is power 2. Okay, that's whole square. So I will take the same values of x minus x power 2. So now that's giving me another value, and drop down and take its sum as well. Okay, let me check if it is correct. X minus x bar whole square. Okay, now I will see that if there is any problem with that. If there is any problem with that, let me check. Okay, so that's fine. Now in order to determine beta 1, I have to subtract this whole term. I have to divide this whole term by this one, so that is equal to, so beta 1 is equal to, that is equal to the first term divided by this term, so that is 0.109, which we have already verified by a software. Now beta naught is actually y bar minus b1 into x bar, so that will be y bar is here minus beta 1 is here, and that is multiplied by x bar. So that will give us another value, which is 98.248, and this is also verified. So let me highlight that. Now we can see here that we already, by using a Minitab software, we obtain 98.24 value for our constant, that is beta naught, and 0.1098 as beta 1, and we have use Excel now to determine these values. So our equation will be the house price is equal to 98.24 plus 0.10109 into square feet. So that is our regression equation, and we can use this regression analysis technique for different other kind of data. So in the student activity, I will give you an assignment. It will not be assignment, it will not be a graded one, but you can take this example and you can solve for your practice. So thank you for today, and that's the end of probability and statistic course.